Alright, let's find the components of the following vector. We have an object displaced 200 meters north of east, and the question is, what are the components of that vector? So let's start here. First thing I'm going to do is I'm going to draw a pair of axes, and these axes are going to be represent for me north, south, east, and west. Now it says it's 200 meters north of east, so I know first thing I'm going to do is look for east, and then I'm going to go north of east. So my vector is going to be something like that. And we put an arrowhead on it to indicate the direction, and we have an angle here that is 27 degrees. Right, now we need to find the components of this. So the component on the eastern side, which we often might say is the horizontal component, would be right here. It would be drawn from the from the origin. We'll make it a little thicker here. Be drawn from the origin out to where this diagonal line comes down from that corner, and then this would be our northern component, or in a lot of cases our vertical component here. Now if you notice, we have two triangles. We have one triangle here, and then we have two triangles, one on top of each other. And these two triangles are useful because essentially the side opposite the angle here is the same as the northern component. So we can use this one triangle right here to find our components. So let's see, what do we want to use? Well, the rule we want to use our trigonomic functions. So ka toa, where if you have a triangle with an angle of theta, this side would be your hypotenuse, this side would be the opposite side, and this side, which is along the angle, would be our adjacent side. So right here we're trying to find the opposite side, so we'd use sine. So the answer to this would be sine 27 degrees equals the opposite, which is what we're trying to find, over our hypotenuse, which in this case is 200 meters. From here we would solve for opposite, so it's op equals 200 meters times sine of 27 degrees. And if we do that all out, I need to do the calculations. Let's pull up our calculator. Go with the scientific one, and I'll pull my calculator over here. So if we do 27 degrees, we find the sine of that, and then we multiply it times 200, we end up with 90.798, which we'll call 90.8. So this side opposite here would be opposite equal to 90.8 meters. Now to find this side, we would use, this is the adjacent side. So here we're going to say that we're going to use the cosine function. So let's move it down here. It's going to be cosine 27 degrees equals the adjacent side divided by our hypotenuse. And coming back over here, solving for that would be adjacent is equal to 200 meters times cosine 27 degrees. Get a calculator here. Clear. 27 cosine times 200 meters equals 178.2. So here, our adjacent is equal to 178.2 meters. And now we have our answer. Here it would be 178.2 meters. And up here, our side over here would be 90.8 meters. And those are our two components for our 200, whoops, I should have wrote it here, 200 meter distance.